Welcome. So in this video we're going to look at limits that involve composite functions. So we saw in the textbook that there's a theorem that allows us to evaluate limits of composite function, and in the specific case where a function f is continuous at x equals b and the limit of g of x as x approaches a equals b. In that case, if I have the limit as x approaches a of the composite function f of g of x, then I'm allowed to put the limit inside the outer function f, and in that case I have f of the limit of g of x, and since the limit of g of x as x approaches a equals b, then the answer is f of b. So as an example, here's the following limit. I have the limit as x approaches 1 of the arctan of a rational function. Now arctan is a continuous function everywhere. So if the limit of what's inside the arctan exists, I will be able to basically evaluate this limit by just taking the arctan of that limit. So let's take a chance and plug in the limit inside the continuous function arctan. Now the limit as x approaches 1 of x squared minus 1 over 2x minus 2, well, if I plug in 1, you'll see that you get a limit of the form 0 over 0. But since it's a rational function, that means that I have polynomials in the numerator and in the denominator, and because by replacing x by 1 I get 0 in the numerator, that means that this polynomial has a factor which is x minus 1. And similarly in the denominator, because when I replace x by 1 I get a value of 0, the polynomial 2x minus 2 will also have a factor of x minus 1. So these two factors should cancel out. So as I said, it's a limit of the form 0, 0, and I factor the numerator and the denominator, and the numerator is actually a difference of squares, so it factors as x minus 1 times x plus 1, and in the denominator I can factor a common factor of 2, and I get 2 times x minus 1, and as expected, I have a common factor of x minus 1 at the top and at the bottom, and I can cancel those two, and overall I get that the limit is the limit as x approaches 1 of x plus 1 over 2, and now there is no problem in replacing x by 1. I can use the direct substitution rule. So this limit exists, it's 2 over 2, which is 1, and my answer could be arctan of 1, but I can actually do a little bit better here. I can try to evaluate if arctan of 1 is some exact value. I could also use my calculator to evaluate it, but I would just get an approximate value. So try to always to think if the answer that you have here, arctan of 1, could I write it in a better way? Now, what's the arctan of 1? Well, an arctan is an angle. So we're looking for an angle where the tangent is 1. And that angle has to lie between pi over 2 and minus pi over 2. So can you think of an angle lying between pi over 2 and minus pi over 2 where the tangent is 1? Remember, the tangent is sine over cosine. So if the tangent is 1, that means then both sine and cosine are equal. So try to think about it. And the answer is that this angle we're looking for is pi over 4, because at pi over 4, both sine and cosine are equal to root of 2 over 2. They are equal. So my limit overall is pi over 4. Thank you for watching.